On July 29, 1944, Captain Howard Jarrell nursed his crippled B-29 superfortress toward Soviet territory. He'd just bombed a steel plant in Anshan, Manchuria, deep in Japanese-occupied territory, and now his fuel gauges were reading empty. The mission had been longer than expected, the headwinds stronger. His crew of 11 men watched the Sea of Japan pass beneath them, knowing they had two choices: ditch in the ocean and hope for rescue, or violate Soviet neutrality and land at Vladivostok. Jarrell chose the second option. He banked toward the Soviet Union. What happened next would change the balance of global power for the next 40 years. When Soviet engineers examined Jarrell's bomber, a plane called Ramp Tramp, they discovered something that would shake their entire aviation industry. The B-29 wasn't just advanced. It was so far ahead of Soviet technology that it seemed to come from another world. Pressurized crew compartments, remote-controlled gun turrets operated by analog computers, radar systems, a central fire control system that could track multiple targets simultaneously. The B-29 was less an aircraft and more a flying computer wrapped in aluminum. But here's where the story gets truly remarkable. Joseph Stalin looked at these captured American bombers and issued an order that seemed impossible. Copy them. Not inspired by them. Not improved versions of them. Exact copies. Every bolt, every rivet, every wire, even the mistakes, and the Soviets had 2 years to do. This is the story of the most audacious act of reverse engineering in aviation history, a technological heist that would give the Soviet Union its first strategic nuclear bomber, terrify the West, and prove that sometimes the most important battles aren't fought in the air, but in secret factories where engineers work around the clock to unlock an enemy's secrets. To understand why Stalin became obsessed with copying the B-29, we need to understand where Soviet aviation stood in 1944. In the 1930s, the Soviet Union had actually led the world in heavy bomber development. Massive four-engine aircraft like the TB-3 amazed foreign observers. The Soviets pioneered long-range strategic bombing concepts and operated the largest bomber fleet on Earth. Then came Operation Barbarossa in June 1941. Germany invaded with 3 million men, and Soviet priorities shifted overnight. Strategic bombers? Too expensive, too slow to build. The Red Army needed fighters. Cheap, rugged fighters that could be mass-produced and thrown into the meat grinder of the Eastern Front. Tactical bombers that could support ground troops. Everything else was a luxury the Soviet Union couldn't afford. By 1944, the only four-engine heavy bomber in Soviet service was the obsolete Petlyakov P-8. Only 79 were ever built. Its range? About 2,400 miles with a light bomb load. Its defensive armament? Manually operated gun positions just like bombers from the 1930s. Its top speed? 272 miles per hour, slower than many fighters. Meanwhile, across the Pacific, America was fielding something that seemed pulled from science fiction. The Boeing B-29 Superfortress represented a revolution in aviation. With a range of 3,250 miles, it could strike targets deep in enemy territory and return home. It could carry 10 tons of bombs, equivalent to 5 fully loaded PE-8s, and it cruised at 30,000 feet, where the thin air meant enemy fighters struggled to reach it and anti-aircraft guns couldn't touch it. But here's what made Soviet engineers' eyes widen when they first examined a B-29. It wasn't just big, it was smart. The B-29 featured 3 pressurized compartments connected by a tunnel that crew members could crawl through. This meant the crew could operate in shirt sleeves at 30,000 feet, while outside temperatures plummeted to 60 below zero. No thick flight suits, no oxygen masks, just comfortable crews who could focus on their jobs for 10-hour missions without freezing or suffocating. Did you know that before the B-29, no production aircraft had ever flown with a fully pressurized cabin? The technology simply didn't exist at scale. Boeing had to invent new sealing techniques, new materials, even new types of glass that could handle the pressure differentials. Then there were the guns. Traditional bombers had gunners manning positions throughout the aircraft, exposed to the cold, manually tracking targets with their hands on the guns. The B-29 changed everything. Its defensive armament consisted of 12 50 caliber machine guns and 1 20mm cannon, all mounted in remote-controlled turrets. Gunners sat at computing gun sights in the pressurized compartments, looking through glass blisters. When they spotted an enemy fighter, they aimed using a sight that calculated lead, distance, and deflection. The guns themselves, mounted in streamlined turrets on top, below, and in the tail, fired where the computer told them to. 5 gunners controlled 5 turrets through General Electric's central fire control system. 1 gunner could control multiple turrets. The system had safety interlocks to prevent them from shooting off their own tail. And the analog computers that made it all work weighed hundreds of pounds and contained thousands of precision parts that Soviet engineers had never seen before. This was 1944. The iPhone was 63 years in the future. Yet here was a bomber with a distributed computer network managing its defensive systems. The B-29 program cost the United States approximately $3 billion more than the Manhattan Project that developed the atomic bomb. Think about that. America spent more money building the delivery system than building the weapon itself. Massive new factories rose in Wichita, Renton, Marietta, and Omaha. At peak production, American industry was completing a new B-29 every hour, and Joseph Stalin had exactly 0 of them. The Soviets first learned about the B-29 in June 1943, when American war hero Eddie Rickenbacker visited the Soviet Union. The details he shared about America's new super bomber must have seemed fantastical. A plane that could fly higher, farther, and carry more bombs than anything in existence, pressurized, computer-controlled guns. Stalin wanted them, desperately. He requested 120 B-29s through the Lend-Lease program, the arrangement where America supplied the Soviets with weapons and equipment. President Roosevelt ignored the request. The B-29 was too advanced, too secret, too valuable. American bombers were needed in the Pacific to bring Japan to its knees. The Soviets would have to make do with their PE-8s. Then fate intervened. On July 29, 1944, that B-29 named Ramp Tramp landed at Vladivostok after bombing Manchuria. Captain Jarrell and his crew expected to refuel and fly home to China. Instead, Soviet soldiers surrounded the aircraft. The crew was taken into custody. The bomber was impounded. Here's where international law created a loophole that Stalin would exploit. Masterfully, the Soviet Union and Japan had signed a neutrality pact in 1941. They weren't at war with each other. This meant that when American bombers, having just attacked Japanese targets, landed on Soviet soil, the Soviets were legally obligated to intern both the aircraft and the crews. To do otherwise would be an act of war against Japan. 11 days later, on August 20th, a second B-29 called General H. Arnold Special made an emergency landing at the same airfield. 3 weeks after that, Ding Hao arrived. A fourth B-29, Kate Paumat II, crashed nearby, killing several crew members but leaving much of the aircraft intact enough to salvage. By September 1944, Stalin possessed 4 B-29 superfortresses and their crews. The American crews, totaling about 300 men from these and other interned aircraft, found themselves in a bizarre situation. They were allies of the Soviet Union, but they were also prisoners. The Soviets couldn't return them without angering Japan, yet keeping them risked damaging relations with America. The solution? The crews were moved from camp to camp across Central Asia, Uzbekistan, Turkmenistan, in conditions that ranged from primitive to tolerable. Eventually, with Soviet complicity, they were smuggled across the border into Persia, modern-day Iran. There they escaped into British territory. The Americans were asked not to publicize their stories so future prisoners could use the same routes. But the bombers? Those stayed in Soviet hands. 3 flyable B-29s were flown to Izmailovo Airfield near Moscow and transferred to the 65th Special Mission Air Regiment. Air Marshal Alexander Golovanov personally oversaw a systematic testing program that ran from January to July 1945. Soviet test pilots flew them. Soviet engineers crawled through every compartment, measuring, photographing, noting. Soviet technicians powered up the radar systems, the fire control computers, the pressurization equipment, and with each flight, each inspection, each test, the same realization dawned on everyone involved. The Soviet Union was years, perhaps decades, behind America in aviation technology. Andrei Tupolev, the Soviet Union's premier aircraft designer, was working on a heavy bomber called Samolet 64. Stalin had been pressuring him for years to deliver a strategic bomber comparable to American and British designs. But Samolet 64 was behind schedule, overweight, and still lacked crucial bombing and navigation equipment. Even if everything went perfectly, it would only match what America had fielded in the early 1940s. Stalin looked at Tupolev's struggling program, then looked at these captured B-29s sitting on Soviet soil, and had an idea. According to historical accounts, Golovanov suggested it to Stalin. Why not simply copy the B-29? Tupolev reportedly objected. So did other designers. Reverse engineering someone else's work was beneath Soviet engineering pride. Besides, it seemed impossible. The B-29 used American measurement standards, inches and pounds, while the Soviet Union used the metric system. The materials were different. The manufacturing techniques were different. The entire industrial base was structured differently. Stalin didn't care about objections. In June 1945, the order came down. The Tupolev Design Bureau would reverse engineer the B-29 and put it into production. Deadline, 2 years. And to ensure compliance, Lavrenti Beria, head of the NKVD, Stalin's secret police, would personally oversee the program. Beria's involvement sent a clear message. Failure meant the Gulag, or worse. Now here's what makes this story truly remarkable. Stalin didn't just want a bomber inspired by the B-29. He demanded an exact copy, down to the smallest detail. Every dimension, every material, every component. His reasoning? If engineers started making changes, deciding what to copy and what to improve, the whole program would descend into chaos. Different parts wouldn't fit together. Production would stall as committees debated modifications. The deadline would slip. No, copy it exactly. Once production was established, then they could make improvements. This meant Soviet engineers faced an unprecedented challenge. Of the 3 flyable B-29s, they chose General H. Arnold Special, named after the U.S. Army Air Force's chief, to be completely disassembled. Ding Hao would remain intact as a reference standard. Ramp Tramp would continue flying test missions, and parts from the crashed Kate Pao Mat-2 would be scavenged as needed. Teams of engineers descended on General H. Arnold Special like surgeons performing an autopsy. Every panel was removed, every wire traced, every component photographed, measured, weighed, and chemically analyzed. Draftsmen working around the clock produced over 105,000 detailed engineering drawings, each one translating American imperial measurements to Soviet metric standards. Think about what this meant practically. An American aluminum panel might be 0.032 inches thick. The Soviet equivalent? 0.128 millimeters. But Soviet mills couldn't produce aluminum sheet to that exact thickness, so engineers had to calculate. Could they use 0.8 minute aluminum instead? Would it be strong enough? Or did they need 0.9 millimeters, and if so, how much extra weight would that add? Multiply that calculation across every single aluminum part in a 74-foot-long aircraft weighing 70,000 pounds empty, and you begin to understand the magnitude of the task. But dimensions were just the beginning. B-29's wiring used insulation made from synthetic materials that didn't exist in the Soviet Union. The plastics, clear panels, instrument housings, ducting were products of American chemistry that Soviet industry had never encountered. The lubricants were formulated to work at extreme altitudes and temperatures. Even simple things like the Zeus, fasteners, quick-release panels common on American aircraft had to be reverse engineered and put into production. You know that Soviet engineers discovered the B-29 used over 9 miles of electrical wiring, 9 miles, in a single airplane. The electrical system alone seemed impossibly complex. Tupolev himself described the B-29 as a logical airframe, dropped into an ocean of electronics. Then there was the fire control system, General Electric's central fire control system was perhaps the most sophisticated piece of technology on the entire aircraft. Analog computers calculated firing solutions. Gyroscopes stabilized the sighting systems. Electric motors trained the turrets. Safety interlocks prevented friendly fire. The system coordinated 5 gunners controlling 5 turrets with 12 heavy machine guns, all while the bomber maneuvered at 300 miles per hour at 30,000 feet. Soviet engineers had never seen anything like it. Some components seemed to come from decades in the future, yet they had to duplicate every switch, every relay, every computing element. Research institutes that had never worked together were suddenly collaborating, sharing discoveries about servo motors and fire control algorithms. Tupolev organized the program with military precision. He divided the B-29 into major assemblies: wings, fuselage, engines, landing gear, systems. Each assembly was assigned to specialist teams. Those teams further divided their assemblies into components. Every component was assigned to a specific research institute or factory, with orders to replicate it exactly. Hundreds of factories across the Soviet Union received drawings and specifications. Many had never manufactured anything remotely comparable. They were told to figure it out. The timeline was non-negotiable. Some manufacturers lobbied to use their own techniques or substitute their own products. Tupolev refused. He knew Stalin and Beria were watching. Any deviation, however logical, might be perceived as sabotage. Besides, he understood systems engineering. Changing one component might cascade into problems elsewhere. The only safe approach was perfect replication. One decision Stalin did allow: engine substitution. The B-29's Wright R-3350 engine wasn't available, obviously. Fortunately, the Soviet Union had been licensing Wright engine designs for years. The Shvetsov Ash-73TK offered 2,300 horsepower, close to the R-3350's output, and shared similar design philosophy. It would fit with minimal modifications. They also replaced the 50-caliber machine guns with Soviet 23mm cannons. Heavier shells, longer range, more destructive power. This actually made the Soviet version more dangerous than the American original. But everything else? Exact copies. By late summer 1946, after over a year of intense work, a full-scale mock-up was ready. Engineers and officials gathered to inspect it. Did it match the American original? Were all the systems present? Could Soviet industry actually build this in quantity? The answer had to be yes. Failure wasn't an option. Plant number 22 in Kazan was hastily converted into the primary production facility. Thousands of workers, many illiterate or barely educated, had to learn entirely new skills. Templates were created, jigs and fixtures were built. Machine tools were calibrated. Quality control inspectors were trained to American standards of precision. Everyone worked 12 to 14 hours a day, 7 days a week. This wasn't optional. This was Stalin's priority. And Stalin's priorities were enforced by Beria's secret police. Remember, Tupolev himself had spent years in prison. In 1937, he'd been arrested on absurd charges and forced to work in a prison design bureau. He wasn't fully pardoned until 1955, 2 years after Stalin's death. He knew exactly what failure would mean for himself and his team. The pressure was unimaginable. On February 28, 1947, the first Soviet copy of the B-29 rolled out of the factory in Kazan. Workers erupted in applause. Tupolev's relief must have been profound. After nearly 2 years of seemingly impossible work, they'd done it. The aircraft looked identical to an American B-29. But looking right and flying right were two different things. The bomber was designated Tu-4, Tupolev's fourth major aircraft design. Though, of course, the designed was a generous term. Cloned would be more accurate. On May 19, 1947, the Tu-4 took its maiden flight. Soviet test pilots, already familiar with the B-29 from flying ramp-tramp, took the controls. The engines roared to life. The massive aircraft, weighing 4,500 pounds empty and capable of carrying 132,000 pounds fully loaded, accelerated down the runway and lifted into the sky. It flew beautifully. Every system functioned. The pressurization worked. The fire control system tracked targets. The remote gun turrets responded to commands. The aircraft handled like a B-29 because it was a B-29, just built with Soviet hands from Soviet materials in Soviet factories. But the real test came 3 months later, August 3, 1947. Aviation Day at Tushino Airfield near Moscow. Thousands of spectators gathered for the annual air show, including Western diplomats and military attachés, who attended these events specifically to assess Soviet aviation capabilities. The show began with fighters performing aerobatics. Then bombers flew past, older designs, twin-engine types, nothing impressive. The crowd watched politely. Then on the horizon, 3 large 4-engine bombers appeared in formation. Western observers lifted their binoculars. Recognition was instant. B-29s. They had to be the 3 American bombers that made emergency landings in 1944. The Soviets were showing them off, perhaps as a gesture of, wait, a fourth bomber appeared. Then a fifth, a modified version with a different fuselage, clearly a transport or passenger variant. The Western observers realized what they were seeing, and the implications hit like a physical blow. The Soviet Union had reverse-engineered the B-29. They hadn't just studied it. They'd copied it, put it into production, and were now parading it overhead for the world to see. NATO analysts scrambled to update their intelligence assessments. If the Soviets could build B-29s, they could threaten Western Europe. They could possibly even reach North America on one-way missions. The bomber was given the NATO reporting name Bull, and within 3 years, over 270 Tu-4s were deployed in Soviet long-range aviation regiments. Did you know that the Soviets didn't just copy the B-29's capabilities, they improved them? Soviet metallurgists, in their quest to replicate American aluminum alloys, actually created some superior materials. The 23mm cannons packed far more punch than 50 caliber machine guns, and Soviet engineers, having learned from the B-29 systems, began applying that knowledge to future designs, but the Tu-4's importance went far beyond its combat capabilities. The program had forced the entire Soviet aviation industry to leap forward a decade in just 2 years. Design bureaus learned new techniques. Factories acquired new capabilities. Research institutes developed new materials. 900 research facilities and factories participated. Over 105,000 detailed drawings were produced. Hundreds of thousands of workers learned precision. Manufacturing the Soviet Union had essentially compressed 10 years of technological development into 24 months through sheer force of will and unlimited resources. And October 18, 1951, a Tu-4 conducted the first airdrop of a Soviet atomic bomb. The RDS-1 nuclear device detonated successfully. The Soviet Union now possessed both the bomb and a proven delivery system. The nuclear age had fully arrived. American planners realized with dread certainty that Soviet bombers could now carry nuclear weapons to American cities. Early warning systems became priorities. Fighter interceptors were redesigned for high-altitude performance. The Cold War arms race kicked into high gear, driven partly by 3 B-29s that made emergency landings 7 years earlier. By 1950, 8 M47 Tu-4s had been built. They served not just as bombers but as tankers, reconnaissance aircraft, missile launchers, drone carriers, and electronic warfare platforms. Some were transferred to the People's Republic of China, giving Mao's regime its first strategic bomber force. The aircraft remained in frontline service through the 1950s, eventually being replaced by more modern designs, including the Tu-16, which incorporated lessons learned from the B-29 but represented a genuine Soviet design, not a copy. There's a famous story, possibly apocryphal but repeated so often it's become legend. Soviet engineers, in their obsession with perfect replication, copied everything from the B-29s, including mistakes. One wing reportedly had an incorrectly drilled rivet hole, a Boeing worker's error, that served no purpose. The Soviet copy had the exact same unnecessary hole in the exact same location, because Stalin's orders were absolute: copy everything. Whether that story is true or embellished, it captures the essence of the program. This wasn't about understanding principles or learning techniques. This was about industrial espionage at a national scale, directed by a dictator who would accept nothing less than perfection, and backed by a secret police force that made failure a death sentence. What happened to the men whose aircraft made this possible? Captain Howard Jarrell and the crew of Ramp Tramp, along with the crews of the other interned B-29s, eventually made it home through that secret escape route via Iran. They'd spent months in Soviet camps, never knowing their aircraft would change history. After the war, they were asked to keep quiet about their experiences. Many did, and some carried the full story to their graves. Ramp Tramp itself flew for the Soviets until the early 1950s, used for test programs and research. It even air-launched the rocket-powered Samolet 346 test aircraft, an experimental near-supersonic plane that represented the next generation of Soviet aviation, built using knowledge gained from studying American technology. General H. Arnold Special, the bomber chosen for complete disassembly, was literally taken apart piece by piece. It ceased to exist as an aircraft and instead became a library of parts, each one a Rosetta Stone for Soviet engineers translating American technology into Soviet production. Ding Hao. remained intact throughout the program, a three-dimensional reference manual. When engineers debated whether they'd correctly understood a component from the disassembled aircraft, they could walk over to Ding Hao and check. Andrei Tupolev, the man who accomplished the impossible under threat of death, lived another 25 years. He continued designing aircraft, creating some of the Soviet Union's most important bombers and passenger planes. The Tu-95 Bear, still in Russian service today, the Tu-114 passenger airliner, the Tu-144 supersonic transport, Russia's answer to the Concorde. But the Tu-4 remained his most important achievement, not because it was original, but because it transformed Soviet aviation. Before the Tu-4, the Soviet Union was years behind the West in aviation technology. After the Tu-4, they were competitive. The lessons learned, the capabilities developed, the confidence gained, all of it flowed from those 24 months of intense reverse engineering. Lavrenti Beria, Stalin's enforcer on the program, continued terrorizing Soviet citizens until Stalin's death in 1953. Within months, he was arrested by his fellow Soviet leaders and executed. His reign of fear ended, but the aircraft program he'd overseen with brutal efficiency had already succeeded. Stalin himself died, never knowing whether his gamble had truly paid off. He pushed the Tu-4 into service and saw it parade overhead. But the full strategic implications, the deterrent effect, the influence on Western policy, the validation of Soviet industrial capability, emerged only after his death. The B-29 itself continued serving America well into the 1950s. During the Korean War, B-29s and Tu-4s existed in the same airspace, American originals and Soviet copies on opposite sides of a new conflict. They never fought each other directly, but the psychological impact was profound. American bomber crews knew that below them, Soviet-trained pilots flew aircraft built from stolen technology. The cost of the program is still debated. The original B-29 development cost America about $3 billion. The Soviet reverse engineering effort's exact cost remains classified, but it certainly ran into billions of rubles and required the participation of a significant percentage of Soviet industrial capacity for 2 years. Was it worth it? From a strategic perspective, absolutely. The Tu-4 gave the Soviet Union credible nuclear strike capability years earlier than they would have achieved through indigenous development. It forced Western nations to take Soviet military power seriously. It validated Stalin's brutal approach to industrial modernization. From a human cost perspective, the answer is darker. Thousands of workers died in industrial accidents during the rushed production. Engineers who failed to meet deadlines disappeared into the gulag. The pressure, the fear, the relentless demands, these extracted a terrible price from the people who made it possible. And perhaps most ironically, the Tu-4 became obsolete within a decade. By the late 1950s, jet bombers made propeller-driven aircraft archaic. The technology Stalin had desperately needed, the capabilities he'd forced Soviet engineers to steal and replicate, belonged to the past. But the industrial base created to build the Tu-4? That remained. The knowledge gained? That persisted. The confidence that Soviet engineers could match Western technology? That shaped decades of Cold War competition. There's a broader lesson here about technology, reverse engineering, and the nature of innovation. When we think about copying versus creating, we usually view copying as inferior, a shortcut taken by those who can't innovate. But the Tu-4 program reveals something more complex. Reverse engineering advanced technology isn't easy. It's not simply tracing blueprints. It requires deep understanding, problem-solving skills, and often more creativity than original design. Soviet engineers didn't just copy shapes. They had to understand principles. Why was this aluminum alloy used here? What forces was this structural member designed to resist? How did this electronic system integrate with that mechanical system? Every answer required analysis, testing, and validation. In many ways, learning by disassembly is one of the oldest forms of technological transfer. Humans have always learned by examining how things work. The Industrial Revolution spread partly through industrial espionage. British textile machinery secrets migrated to America through copied designs and recruited experts. Weapons technology has always flowed from victor to vanquished, from advanced to developing nations. What made the Tu-4 program unique was its scale, its speed, and its completeness. an entire aircraft, down to the molecular level, replicated through national effort under brutal pressure. It also reveals something about Stalin's Soviet Union. The system was capable of marshalling incredible resources and achieving remarkable results when directed toward a clear goal. But the human cost, the fear required to drive such efforts, and the inflexibility of the approach also showed the system's flaws. Innovation happened through brute force, rather than creative freedom. The crews of those 4 B-29s that landed in Soviet territory in 1944 had no idea they were delivering the blueprints for Soviet strategic air power. They were just trying to survive, to avoid ditching in the ocean, to make it home eventually. Captain Jarrell, making that decision to turn toward Vladivostok instead of gambling on a water landing, couldn't have known his bomber would be disassembled into thousands of pieces, each one studied and copied, ultimately spawning 847 Soviet clones. Sometimes the most consequential decisions are made without any awareness of their eventual impact. The Tu-4 flew its last combat missions in the 1960s. Most were scrapped. A few survive in museums in Russia and China. If you ever see one, look closely. It appears identical to an American B-29. The wings, the fuselage, the tail, the engines, all familiar. But remember that every component was manufactured in Soviet factories by Soviet workers using Soviet materials, all guided by 105,000 engineering drawings created from a disassembled American bomber. It's a monument to industrial espionage, to reverse engineering, to Stalin's brutal efficiency, and to the engineers who accomplished something impossible under threat of death. In the end, the story of the Tu-4 isn't really about bombers. It's about what nations will do to close technological gaps. It's about how knowledge transfers even when one side desperately tries to keep secrets. It's about the engineers who, given impossible tasks and lethal deadlines, somehow find a way to deliver. When those 3 Tu-4s flew over Tushino airfield in August 1947, they were more than aircraft. They were a message. The Soviet Union had arrived as a modern military power. They'd closed the gap. The technological advantages the West had enjoyed were eroding, and it all started with a B-29 named Ramp Tramp, limping toward Soviet territory with its fuel tanks running dry, carrying 11 American airmen who just wanted to get home, and inadvertently delivering the secrets that would reshape the Cold War.